All right, this is going on page 52 and we're done. On Thursday, we did polynomial sign charts and inequalities. Today, it's rational sign charts and inequalities. So let's talk about the difference, first of all, between a rational and a polynomial. So you know what polynomials, what the equations look like. This is an example of a rational function, okay? It's not just that it's as a fraction, because the definition of a rational number is that you can write it as a fraction. But let's say that if I had, and you don't have to write these down, but let's say that I have x squared over 7. Even though that's written as a fraction, and that's kind of what the rational function looks like, this is not a rational function because I can write this as 1/7 times x squared. Does that make sense to you? So just because it's a fraction doesn't make it irrational. In order for it to be a rational function, you have to have variables in a function in the denominator. So it's really like one function divided by another. So you have to have variables in the denominator. You don't necessarily have to have them in the numerator. You can, but they absolutely have to be in the denominator to make it rational. Okay. All right, so when we talk about the definition of a rational inequality, it says given a rational function f of x, rational inequality has the general form of all of this, which is exactly what it looked like for a polynomial. It just had the words polynomial inequality there because it's just the function is what it is. So if I have the inequality f of x is greater than 0, that is true when f of x is what? Positive. Good. Because f of x represents what? Y, yes. And then f of x is less than 0 when f of x is negative. All right, so what comes along with rational functions are asymptotes, okay? And in this particular function here, we have a few asymptotes, so let's look at where they are. You see this part of the function is going here to infinity. This part's coming down here to negative infinity. So in between there at -3, I have a vertical asymptote. Here we're going to infinity. This is going to negative infinity. At 2, I have a vertical asymptote. And then here, this doesn't go straight down to infinity. This is, tapering off somewhere, and this is tapering off kind of that way. So we also have a horizontal asymptote at y equals 2. So one of the things that's happening in this function that you may not have ever seen before, or very little, I'm pretty sure I talked about it a tiny bit, not really in detail, but we talked about asymptotes a little bit before, is that you may have been told that your function cannot cross the asymptote, period. Well, clearly that's not true because this part of the function crosses that horizontal asymptote, right? Totally legal. Not only but because this horizontal asymptote deals with end behavior, it has nothing to do with what's going on here anyway. So way out here at the end, as x approaches infinity, f of x is approaching 2, right? And as x approaches negative infinity, f of x is approaching 2. Has nothing to do with this part anyway. Even though it deals with these parts of the function, this function could come up over the asymptote and then still approach 2 as it goes to infinity. So just know that you can cross a horizontal asymptote. You cannot cross a vertical asymptote, though, because that affects domain. All right? At a vertical asymptote, that means that there is not a single y value that you can put with x equals -3. Like, it's not possible. Right? We all good on that? You graphed rationals in Algebra 2, so they are not brand new to you. Asymptotes are not brand new to you. The only part that might be brand new to you is just the fact that you can cross them like this. Okay, so with all that said, it says we're going to look at this, name all the intervals for which f of x is greater than 0. So that's when it is positive. So my function is positive here, and here, and here. So all the places where the function is greater than 0. All right, so it starts being positive out here at negative infinity. The function remains positive until we get to -3. I never include my infinities. I'm also not including -3 because that is a vertical asymptote and I can't reach it anyway. It starts over being positive at x equals -1, so I union that with -1 to 2. And then it starts over being positive again at 1, 2, 3, 4. and goes to infinity. Any questions about the positiveness of that function? Okay. So then we look at when it is less than 0, so that's when it is negative. So it's negative here, and it's negative here. So where does this function start being negative? Negative 3. Is it negative 3 or is it negative infinity? What are we talking about? When we're talking about positive and negative, are we talking about the y's being positive or negative, or the x's being positive or negative? Y's, right? So we're talking about y. What do we write about? X. So when does this start becoming negative? Negative 3. Yes, the y starts at negative infinity, but that is not what we're looking at. Yes, it's negative this whole time, but it starts being negative. We are writing intervals of the domain. So it starts being negative at negative 3. It remains negative until we get to negative 1. Open, open. It starts over being negative where? Negative infinity again? No, where? 2. And then it stays negative until we get to 4. And it's open because at 4, it's 0. It's not negative. Okay, everybody good with that? Any questions at all? Okie dokie. So here's one thing. Here's another main difference between rationals and polynomials. On a polynomial, because it's continuous from negative infinity to infinity, the only time it can change from being positive to negative is when it crosses through the axis, right? So it can only change from positive to negative or vice versa at the zeros. But this says, notice that a rational function can switch signs at its zeros and its vertical asymptotes. So here, my function was positive. I have a vertical asymptote at x equals negative 3, and it went from positive on one side to negative on the other side. So that's one place where it switches signs. It can also switch signs at its zeros. And again, it switches signs here at its asymptote. And a key word here is can. Doesn't mean that it does, right? Because it could be tangent. It could bounce off and not change from positive to negative. Or this asymptote, it could look like this on this side and this on this side. Maybe it's still positive on both sides, just depending on the function. Okay, so the key word there is can. Doesn't mean that it has to. Okay, we all good with that? All right, these are very, very similar to the polynomial sign charts and inequalities. Most of the directions are the same. We set it equal to 0. We find the zeros, but this time we have to do it in the numerator and the denominator by factoring if necessary. Sometimes you don't have to factor. Plot these points on a number line, and here's a key here. Asymptotes always get an open circle. So your points, if it says equals, then yeah, we get closed circles. But on inequalities, it can change depending on the symbol. But regardless of what symbol you have there, the asymptotes are always open because you're never gonna have a value on that point. Okay, does that make sense? Or on that x value. All right, and then we do the same kind of thing with the sign chart. So let's see how this works. So we've got to pick two things here. We're going to set it equal to 0, first of all. So equals to 0. So if my numerator is 0, if I have 0 over x plus 2, what is the function value? If you have 0 over anything, what's the value of that? 0, okay? What if I have 0 in the denominator? It's undefined, right? And look up those little posters up there if you forget. N, no, so n over O, that's undefined. That's a big fat no. That's like n over 0. Yeah, it's okay if 0 is in the numerator, that gives you 0, okay? So if you get it backwards in your brain, think about those things and don't mess it up anymore. You cannot afford to do that. So tell me, on this graph right here that we just looked at, when is this function undefined? When do we not have a y value at all? It's impossible. The asymptotes, which ones, horizontal or vertical?
Horizontal.
This means I can't have a y value at all? No. It's the vertical one. See here? At x equals negative 3, the reason we have a vertical asymptote is because that's where the function is undefined. There is not a y value that works when x is negative 3. The function is undefined, okay? It's also undefined at x equals 2, right? There's also other ways for it to be undefined. We'll get to that. But right now we're just looking at asymptotes, okay? So that means that if I can make this, if the denominator is 0, I'm going to have a vertical asymptote. So when I find the zeros of the numerator, that gives me the zeros of the function. These zeros of the denominator give me the asymptotes, the vertical asymptotes. Okay? So we're going to take this, and we're going to say, okay, the first thing I want is I want my zeros. Right? And that comes from the numerator. So that's fairly, I don't even have to factor here. So my x value for my 0 is just -5. Okay? So when x is -5, y is 0. That's what that means. Then if I want the vertical asymptotes, I'll write it out this first time. Vertical asymptotes, that comes from the denominator, the zeros of the denominator. But I don't put them in little brackets because asymptotes are lines. So x plus 2 equals 0. This is what I do. X plus 2 equals 0. You don't necessarily have to write it down, just making sure we know where this comes from. So my vertical asymptote is actually x equals -2. That is an equation of a line that is not a statement about an x value. Okay? Which I know it looks the same as the statement of an x value, but you have to know in context what you have there. Okay? Everybody with me so far? So I have two things that go on my sign chart. I have -5 and I have -2. So -5 is a 0, so it gets a closed circle. -2 is an asymptote, so it gets an open circle. Then I'm going to create my sign chart pretty much the same way. For the polynomials, I lined up my signs this way because the polynomial was just like one continuous thing. But here I have a numerator and denominator, so I'm going to kind of stack them, everything in the numerator over everything in the denominator. But I'm not going to put a little fraction bar because then that's going to look like a negative, and that can get very, very confusing. And the last thing we want to do is confuse ourselves. So I'm going to take -6 because it has to be less than -5. When I substitute -6 in here, the numerator is negative. -6 down here, the denominator is negative. Negative divided by a negative is a positive. Between -5 and -2, I can choose -3. So -3 would give me positive in the numerator, negative in the denominator. That's negative overall. Then I can choose 0. So 0 would give me positive, positive. So that is positive overall. And then I shade positive, negative, positive. Any questions at all? So like I said, very, very similar. And if you've already done that assignment, then you've practiced and it makes sense. And we're just adjusting it a little bit here. All right, so let's look at number 2. We're going to set this equal to 0. And then we're going to factor. So the numerator, I don't need to factor, obviously. It's going to equal 0. The denominator, let's see, I'll have x and x. Two numbers that multiply to give me 6, combined to give me -5. -6 and 1. Are 2 and 3 kind of tempting? Because 2 plus 3 is 5, right? But because this is negative, the signs have to be opposite, so it doesn't work. All right, so now that I have this, right, I get my zeros, so I'm just going to put a little z for zeros. They come from the numerator. So that is just 0. My vertical asymptotes come from the zeros of the denominator. So that means my vertical asymptotes are going to be x equals 6 and x equals -1. And they are equations of lines. You write them as equations of lines, or you will get them wrong. Okay? What questions you got? All right, 3 things that go on my sign chart. So I have -1, 0, and 6. Totally not to scale. Not really worried about that on my sign chart. More worried about room for me to write my little signs. So my 0 gets a closed circle. My vertical asymptotes get open circles. So then I'm going to choose points. Don't forget the end. Sometimes people do like the middle stuff and forget to go on either side. So I'm going to take a -2. I'm going to substitute it into this one right here. So -2 in the numerator is going to be negative. Then that would be negative, negative. So that is negative overall. I can substitute in like a -1/2. So that's going to give me negative, negative, positive, which is positive overall. Then I can use 1. So that would be positive, negative, positive. Then I can use 7, which would be positive, positive, positive. It's positive overall. Okay, shade it, then don't flip it over yet because we're not done with this. Negative, positive, negative, positive. Okay. So, even though I know you have graphed rationals before, we have not actually talked about graphing them yet, but we can sketch a pretty good version of this here, just knowing what we know. First of all, we know that we have asymptotes at -1 and 6. So I'm going to sketch and say, okay, these are my vertical asymptotes. Then there's some things that we know about vertical asymptotes. If I have a vertical asymptote, and you don't necessarily have to write this either, but if I have a vertical asymptote, my graph either has to be coming up like this or going down like that next to it. I'm never going to have a vertical asymptote and it go like this and like stop, unless it's a piecewise function. Like that doesn't happen. Okay? It has to either go to positive or negative infinity when it comes up to that. So when I come over here, I know that starting out at negative infinity, my function is positive. Okay? So it's positive, so it's going to have to come in here. And I know it's going to have to be decreasing because it's going to come like this. Since I have a vertical asymptote here, it's going to have to, since it's going to stay negative, has to look like this. So this part of the function has to look like that. So I have a horizontal asymptote somewhere. It could be at y equals 0. We don't know for sure right now, but we do know that this isn't going to become positive, so it's not going to cross the axis. Okay? Then I know on the other side of the asymptote, since it's positive here, it's going to look like that. For this asymptote on this side of it, it's negative, so it's going to have to look like that. And then to connect these two, I have to go through this point right here. I have to cross through the axis right there, so it's going to look something like that. Then on this side of the asymptote, it's positive, so it has to look like this. I don't get to cross through the axis, so I'm going to have a horizontal asymptote somewhere, and that's basically what your function looks like. Okay? Once we learn about and talk about a few other things we can glean from this, we'll be able to get a little bit more like what is our y-intercept, what are a couple of exact points to help us, where is our horizontal asymptote, but this tells us a ton right here. Okay, gives us the general shape, a little sketch. Okay, we good? So this is sketching. We're not really going to sketch these. I just wanted you to see how this works. We're really going to graph them, but this gets us kind of the sketch part. Gets us at least the shape. There's a lot we already know. Okay. All right, so let's flip this over. I'm going to look at number 3. All right, so I'm going to set this equal to 0, and I'm going to factor. 0 equals, so the numerator I get x plus 3, then x minus 3, and then x plus 4 down here. So my zeros, I get my zeros from where? Numerator or denominator? Numerator. So my zeros are -3 and 3. And I get my vertical asymptotes from where? Denominator. X equals -4. And again, that is an equation of a line, and you write it as an equation, not as like a set of numbers. Those are two completely different things. So then I have 3 things to put on here. Got -4, -3, and 3. You complete this sign chart so I can make sure that we all know how to complete the sign chart. When you're done, check yours with mine. Make sure your circles are opened or closed as necessary, and let me know if you have any questions, because if you don't know how to do this, we don't need to move on yet. Are we good? Okay, so we're going to skip number 4. We're going to move on to the inequality part of it, which is kind of what we, part of what we want to look at. We don't need to do number 4. So just like with the polynomials, it's the same steps, but then you use it as an inequality. Okay, and it does say, we're supposed to set it equal to 0, but it's not really equal, whatever. You know what it means. Legally on one side, you got to have a 0, which this one does, so that's great. So we are going to factor. When I factor the numerator here, I'm going to get x and x. And what are my two numbers? -4 and -1, yes. So I'm going to do -1 and -4 just because of my parentheses space. That was accidental. I don't really have room for a 4 in there. And then in the denominator, I got x times x plus 2. Oh, yes, no, that's right. And that is less than or equal to 0. So come over here, my zeros, x equals, this will be 1 and 4. How many vertical asymptotes do I have? 2. I have one at x equals 0, and I have one at x equals -2. Don't forget about that 0. He's very important. Okay. All right, so I have 4 things that go on my sign chart. Let's see, I start here at -2, then 0, then 1, then 4. So inequalities is where I have to pay closer attention to my open and closed circles. I have, my vertical asymptotes always get open circles. So these two are open. And then whether or not the zeros are opened or closed are dependent on this. That says less than or equal to, which means these are closed circles. Then we go about our sign chart the exact same way. Start with a -3. So this will be a negative and negative in the numerator, and then negative and negative. That is positive overall. Then I can choose a -1. So that'll be negative, 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 positive. That's negative overall. Then 1/2, which would be negative, negative, positive, positive. That's positive overall. And then 2, this is going to be positive, negative, positive, positive. It's negative overall. 5 will give me positive, 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 positive. Now, every single one we've done so far alternate. Just know that they don't always all alternate. Okay, just what's happening right now. There are going to be some other ways where we may not have to always put in all the signs if we know other things, but right now we're doing all of the signs because we haven't talked about the rest of the stuff that you could actually know yet. So then I have, so this is positive, negative, positive, negative, positive. So far, this is almost exactly like what we did on the front. But this is an inequality, and we have to actually write the solution to that. If it's less than or equal to 0, that means we want these negative parts here, right? And then I pay attention to my open and closed circles. That tells me whether or not my intervals are open or closed. So it is negative from -2 to 0, and these are both open because these are both asymptotes. And then I union that with, I'm going from 1 to 4. These are closed circles, so these are closed intervals with the brackets because that's where it's negative or 0. What questions do you have? Understand how to get the intervals? You're not going to get the correct intervals if you didn't do your open and closed circles correctly, so watch out for that. Any questions at all? All right, let's move on to number 7. All right, so remember, we have to have 0 on one side. So I have to move that 1 legally, which means it's going to give me x minus 7 over 2x minus 2 minus 1 is greater than 0. Okay? I can't start factoring, I can't start finding zeros or anything else until I have a 0 over there and I have this combined. So this has to be one rational statement. Is this going to be x minus 8 over 2x minus 2? No. When you subtract fractions, what do you have to have? Common denominator. What would my common denominator be? 2x minus 2. Okay, so my common denominator is 2x minus 2. This first numerator is x minus 7. This 1 had to get multiplied by 2x minus 2 over 2x minus 2. So the numerator here that I'm combining with, I'm going to do minus, parentheses, 2x minus 2. And that's greater than 0. So then I'm going to combine all that. It's in the numerator. My denominator is 2x minus 2. So this gives me, so x minus 2x is negative x, and negative 7 minus a negative 2 is a negative 5. And that's greater than 0. Then I factor. And I highly suggest that if x is negative on one of these, that you actually factor out a negative. You don't have to, but you're going to have to reason around things where I don't want you to get things mixed up, so it's just way better to do that. So I'm going to factor out my negative, so I get negative x plus 5 over, then I can factor out a 2, and that gives me x minus 1. That's greater than 0. Then from that, so I went up here. From this, I'm going to get my zeros, which is just going to be negative 5. And I'm going to get my vertical asymptotes, which is just going to be x equals 1. Okay. Two things that go on here. I've got a negative 5, and I have a 1. So my vertical asymptote's always open, totally open. Is my negative 5 going to be opened or closed? Open, because this just says greater than 0. It does not say greater than or equal to 0. So they're both open. Now, when I go to substitute in signs, or substitute in to figure out my signs, I only have one factor in the numerator, but I have two signs that I have to take into account. I have whatever this gives me, and this one, which is negative every time. So I start with a negative in the numerator. And then I have, let's say I choose negative 6. So negative 6 plus 5 is going to be negative. Now, I know what some of you are thinking. You're thinking, well, couldn't I just look at that, know that that's negative, and then that negative makes it positive? Yes, but if you have a negative out front and you have like 4 factors, when you're writing them down, you're not reasoning through that. I suggest you just put it out here. It's just going to make things easier. Okay? In the denominator, does this 2 affect the sign of anything? No, so I can just ignore that guy. So negative 6 minus 1 is negative. So that makes this negative overall. Okay, so when I substitute in 0, I still have this negative out front in the numerator. Then 0 inside of here is just going to give me positive, and then it's going to give me negative in the denominator, so that's positive. Then I can substitute in a 2, still have this negative here, then that's positive and positive, which makes this negative overall. So then I'm going to shade negative, positive, negative. And I want this, since it's greater than 0, that means I want it when it's positive. This is what I'm looking for. So I go from negative 5 to 1, and that's open, open because of the circles that I have on the number line. Okay. Any questions at all? All right. So let's look at number 8. Can I start finding zeros and asymptotes right here? No. I have to have a 0 on one side legally. Now, in this case, really, it doesn't matter which side you move it to, but I think more of us probably naturally move things to the left, so we'll move it to the left. So I get 9 over x minus 4 minus 8 over x minus 3. That's less than or equal to 0. I need a common denominator. I can very easily get that my common denominator would be x minus 4 times x minus 3. So I know then that, oops, if I can actually see this fraction has to get multiplied by x minus 3 over x minus 3, so that numerator becomes 9 times x minus 3, minus this one has to get multiplied by x minus 4 over x minus 4, so So this is 8 times x minus 4 is less than or equal to 0. So I skipped the step where I write them with common denominators as two separate fractions. You don't have to skip it, but I'm going to because I know not everybody needs to see it because they understand fractions, as we all should. So we've just got to get on board. I don't know. All right, so then we're going to move it up here and clean it up some. My denominator is still x minus 4 times x minus 3. So 9 distributed in here is going to give me 9x minus 27. And then negative 8 distributed will give me negative 8x plus 32, which is less than or equal to 0. I'll clean it up one more time. X minus 4 times x minus 3 in the denominator. So 9x minus 8x is x. Negative 27 and a positive 32 is a positive 5. So from here, any questions on how I got that using my fraction skills? Okay, then I want you to find your zeros, your asymptotes, make your number line, answer the question, whole 9 yards on your own. I'll write little pieces up here as we go. If you get stuck on something, let me know. Just copy mine down. Oh, shoot. I hope you weren't copying mine down because I don't have the right numbers. So when you're done, if you agree with me, then we're good. Go ahead and tape it in. If you do not and you have questions, let me know.